inequalities. Okay, so this is saying what? It stopped at a certain point. So the blue line is this guy. I know that's kind of hard to see on y'all's paper. And then orange is this guy, right? Okay, so what were you saying about this piece right here? This x is less than 4? Okay, so let's talk about that really quick. So with inequalities, it's whichever way the alligator mouth is facing, that's the greater number. So if I had like something like this, 8 greater than 3, 8 is bigger than 3, right? So the alligator mouth is pointed towards the bigger number. Okay, if we turn it the other way, 3 is less than 8. So x is less than 4. Right. Now this line right here that's underneath, that's equal to. So how do you read this one? Well, we gotta say the other thing too, right? So it's x is greater than or equal to 4. Does that make sense? Okay. All right. So today we're going to talk about writing equations of a piecewise function represented in a graph. Okay. So looking at these for piecewise functions, this first one that they give us is negative x plus 7. Okay. So the way that you graph this is you graph the y-intercept, which is 7. I'm going to do this as my y-intercept, which is 7. I'm going to go down 1 over 1, down 1 over 1, and I'm going to draw that line. Now this right here tells me that I want to do less than 4. I'm going to go to where x is 4, which is right here, and I would draw from this line all the way over. It's almost like taking a snapshot. You see the little dotted box that they drew? So you would not include this piece because that's bigger than 4. On the next one that they give us, you have x minus 1. So we would graph the y-intercept at 1, and then we would do the slope. And they want us to look at when x is greater than or equal to 4. Okay, so they have this snapshot right here, and you would ignore all this stuff. Okay, that's this piece that's down here because they have this restriction. So looking at our inequality that we were talking about, this is saying only look at x is bigger than or equal to 4. Only look at x is less than 4. Yeah, it's kind of like when you're cropping a picture and you want to make it a little bit smaller, you're focusing in on the most important piece. Okay. Now, when we actually put these two equations together, we're going to get this picture down here at the bottom. Okay. That's how we do a piecewise. Literally, you're taking pieces of a graph and putting it together. Okay. So how these are always written is you say f of x is equal to, and they use this little bracket to say that these two pieces are going to go together. Okay. Now, here are our domain restrictions. So if x is less than 4, so give me a number that's less than 4. 2? Okay, so if we had x was equal to 2, we would plug into this equation. Okay, so we would do that, and we would get negative 2 plus 7, which would give us 5. Give me a number that's bigger than 4. Okay, so if we took 6 and we plugged it into this equation, we would get a y value of 5. So we would plot the point 6, 5. Okay, this is telling you which equation you're going to use based off of this domain restriction. All right. So I think you might have seen something like this on your SAT. Maybe there was an absolute value probably on there. So we're going to use the graph to write the absolute value function as two separate equations. Okay, so if we plug in, I'm sorry, let's start with this. What does absolute value mean? What does absolute value mean? Oh, you're talking about absolute max and min. Well, kind of similar. When we see these two bars, this means you're going to turn it positive. Make it positive. Okay, so when you see the absolute value, you're going to turn the number positive. Okay, so for instance, if I plug 0 into here, what would I get? It's not a trick question. If I plug in 0, what would I get? 0, right? Yes. So I would plot the point 0, 0. If I plugged 1 into this equation, what would I get? 1. If I plugged in 2, I would get 2. If I plugged in 3, I would get 3, and so on and so forth, right? Now, if I plugged in -1 into my equation, with these absolute value bars, that means I'm going to produce a positive 1. So if I plug -1 in to the absolute value, I'm going to get positive 1. I'm going to plot the point -1, 1. So what if I plug in the point, or the x value, -2? What would that give me? If I plugged in -2 into the absolute value, what would that give me? Positive 2. So we would have the point -2, 2. Same thing would happen for -3. Same thing would happen for -4. And so on and so forth. So what shape does this kind of make? What shape is this? It's a V, right? So we want to write out an equation or a piecewise function for this absolute value. Okay. So if we had f of x and we plugged in a positive number, we got the positive version of that number, right? Yes. So we would have x, and that was if x is greater than or equal to 0. So for any positive number, if we plug it into this equation, we just get the positive number, right? It doesn't change anything. But if we plugged in a negative number, we would have to make it a positive number. So that's where we're going to use the absolute value. So we're going to say x is less than 0. I'll give you a second to write that down. All right, so now we're going to use the graph to write the absolute value function as two separate equations with this new graph, okay? So if I took 0 and I plugged it into this equation, what would I get? Well, if I plug in 0, I would get 5. So we would put a point at 0, 5. If we plugged in 1 into this equation, so positive 1, we would get 4. If we plugged in 2 into this equation, we would get 3. If we plug 3 into this equation, we would get 2, and so on. Now let's work on our negative numbers, right? If we plugged in -1 into this equation, that would make this positive 1, but since there is a negative outside, that's going to make it -1 plus 5, which would give us 4. Okay. I would plot all of our points. I'm going to do it pretty quickly for you. And if you are not sure on this, you could take this and you could type it into Desmos. The way that you type absolute value into Desmos is you hit Shift and then the backslash button. On your computer, if you look, there is a like vertical line that makes a absolute value symbol. So now we're going to write this as a piecewise function. So we're going to say f of x is equal to, we're going to use our little bracket, when x was bigger than 0, because it seems like this is the division line, right? So when x was bigger than 0, when x was bigger than 0, how did we get our numbers? Did they change any? Well, it automatically made this number negative, right? So we can write the equation as negative x plus 5. We are going to say that it's equal to, because it doesn't change anything. When x was negative, we wouldn't have to use the absolute value because this number out here is already negative. So we're going to write this out as x plus 5, and we're going to say when x is less than 0. So we would take the negative numbers and plug it into this equation. The reason why we're using this equation is because it has a negative out front. All right, so if I took this equation, I'm going to show you the Desmos way to do this. Okay, so I'm going to take this equation, I'm going to type it into Desmos to make our lives a little bit easier. And remember, the way to put in absolute value is to hit Shift and that backslash button. You could also go in the functions, and I think there's a way to do absolute. Okay, maybe not. Maybe it's just ABS. Nope. All right, so you're going to hit Shift backslash. And this is the graph that they give us. Okay, so if you want to take a moment, go ahead and plot these points on your paper. And you may not be able to plot all of them. Go ahead and plot as many as you can. All right, so we see that the V happens over here. Okay, so at x equals 4, there's a division, right? So when we write our piecewise function for this, we're going to say x is less than 4 and x is greater than or equal to 4. Those are going to be our domain restrictions. Again, the reason why I'm taking 4 is because that's the division line. That's where like the V happens. If we're on the right-hand side of 4, so let's pick the number 5. And we plug in 5 into our equation. Okay, what happened was we got 2 times 5 minus 4. 5 minus 4 is going to give me 1. So that's just 2 times 1. Okay, if we take any number that's bigger than 4, this equation is just going to be written like this. So you can write it without the absolute value. If we have a number that's less than 4, let's say we plug in 3. If we plug 3 into this equation, we would get 3 minus 4, which is -1. And if we take the absolute value of -1, that would give us +1. So we would get 2. Okay, so the way we would write this out is we would say 2 absolute value of x minus 4, because we would have to use the absolute value bars on this one. All right, so what's 2 things that you notice about absolute values? What's the shape of the graph look like? Yep. Yeah, go ahead. What's the shape of the graph look like? What does it look like? All right, it looks like a V. V-shaped graph. All right. The other thing about absolute value functions is we've got bars. It's going to make things positive. Okay. All right, so for the transformations that happen in here, very similar to what we've seen in the past, A is going to deal with our up, down. A is going to deal with our stretch or shrink. And that negative is going to be a reflection across the x-axis. Go ahead and get those down. We'll talk about H in just a second. All right, so H is going to deal with our left, right. Remember, it's going to be opposite of the sign. Okay, this is going to be opposite of the sign, left, right. So if it's negative, it's going to move right. If it's positive, it's going to move left. Okay, so what does the graph look like? We already kind of talked about this. It's going to be a V shape. Okay, so something like, ooh, that's not a straight line. Something like this. The vertex or the max or minimum value is going to be H, K. And so, for instance, like this one would be 0, 0. The y-intercept is wherever it's going to cross the y-axis. So for instance, when we were doing our Desmos on the last problem, we were doing our Desmos on the last problem. For instance, this guy. Okay, our y-intercept happened at 0, 8. Okay, so when we plug in 0 into this equation, that's what gave us our y-intercept. Okay, so substitute in x for 0, and it's where it crosses the y-axis. So for instance, on this example, we had it cross at 0, 8. For our x-intercept, that's when our y is 0. So we're going to substitute in when y equals 0. And that's where it crosses the x-axis. Fortunately, on this first one, this is the parent function. This is the OG of this type of function, okay? So the way you graph this is you plug in your x values. So if I plug in x into here, remember, absolute value just means make whatever number is in there positive. So this will be 0, 0. If I take 2 and I plug it into this equation, I would get 2. If I plugged in 4 into this equation, I would get 4. Over here, if I plug in -2 into this equation, that's going to give me a positive 2. If I plug in -4 into this equation, I'm going to get positive 4. And ta-da, it looks like a V, like the flying ducks. Yep. Remember, you always have Desmos as your backup, so if you don't know how to graph well, that's okay. You've got your graphing calculator. Okay. Over here, we're going to talk about the transformation first. We got a negative chilling out front. That means that there's going to be a reflection across the x-axis. Oop, can't write axis. There we go. Okay. We've got a 2 also out in the front. That's going to be a stretch of 2. And then we have a +2 on the outside, so that's going to be up 2. All right, so now we're going to take a couple of points to plug in. Okay, again, if you're not super great with the whole graphing thing, Desmos. But we're going to try to do this by hand. So if we plug 0 into this equation, we would get -2, absolute value of 0, +2. Well, what's the absolute value of 0? Well, it's just 0. 0 times -2 is just 0. 0 plus 2 would give me +2. If I take the number 2 and I plug it into this equation, well, the absolute value of 2 is just 2. -2 times 2 is -4. -4 plus 2 is -2. So this will be a point 2, -2. If I take -2 and plug it in, what will happen here is this will become +2. -2 times +2 will be -4. -4 plus 2 is -2. So we'll have -2, -4. I'm sorry, -2, -2. We're going to take 4 and plug it in. Well, this will give us -8 plus 2, which is -6. So we'll have 4, -6. I can't see. 1, 2, 5, 6. I'm going to go ahead and tell you right now that on the opposite side, that's going to be the same. Okay. Fortunately, for absolute values, they are symmetrical. Okay, so wherever that vertex is, they're going to be the same on both sides. Majority of the time, unless you're dealing with piecewise. All right, let's talk through number 3. We've got 1/2 filling out front. So that's going to be a shrink, okay, of 1/2. All right, we got a 3 chilling on the inside. Remember, that's opposite of the sign, so that's going to be left 3. And let's say I'm feeling lazy today and I don't want to hand graph this and go into Desmos. I'm going to type 1/2. Remember, how I get the absolute value is I hit shift backslash, and then I'm going to type x plus 3, and then finish it with absolute value. Boom. So here's a couple of points that we can graph. Oof. Let me pull up the table. Okay, so go ahead and take a moment, graph this on your paper. One thing that people mess up on is whether they call it a shrink or a stretch. Remember, if it's less than 1, it's going to be a shrink because we're compressing the graph. Notice how it's a little bit like wider than what our last graph looked like. On the last graph, we had a stretch, so we pulled it a little bit to be like skinnier. Okay. So that you can get it down. So we're talking about number 4. So it says, given a function, absolute value of x, write the resulting after reflecting across the x-axis and a vertical shift down 4. So this would be my equation, right?